Hello, Math 150 fans. We're back looking at section 6.4. We're going to be talking more about doing trigonometric identities. I just want to show you the screen again. Remind you, these are the identities that we are familiar with that we'll be using. The Pythagorean identities, anytime you see a trig function squared, could come in handy. The reciprocal identities, anytime we want to turn one trig function into another, we have these options. The definitions down here of tangent and cotangent to get them looking like sines and cosines. And then, of course, the odd functions when we've got a negative on our angle, and then the even functions, also with a negative on our answer, but a different result. Negative, the odd, the negative jumps to the front. The even, the negatives disappear. Okay, so we're going to be working with some trigonometric identities again today. And the difference between this one and the last one is we are going to try to establish or prove that these identities are true. Okay, we're going to try to prove that these identities are true. So the way we're going to do this is we're going to pick a side and we're going to leave it alone. And then the other side, we're going to manipulate it to make it look like the side we left alone. Now, the first thing I notice here is I've got a little bit of a typo. I want tangent squared. And then in the second line, I left out that square. So let me just put that right there, okay? What I'm doing here is I'm picking the side I want to leave alone, and I want to leave the tangent squared alone. It's the most simple of the two sides. Usually that's the idea. We leave the simple one alone. So I'm going to just reverse it because I just want to have more space to write on my screen. So same exact equation, but I'm leaving tangent squared alone. That's going to stay on the left-hand side. Now, as I work through this, the idea is what algebra, what trigonometry do we have at our disposal to help us manipulate this? Because we've got to make that right side look like that left side. The examples you're looking at with this video, we're going to be doing a lot of factoring and foiling because that's a really good tool we have at our disposal. So I look at this, and the first thing I think is foil. I mean, there's no way I'm not thinking foil when I look at this. So when I'm foiling this out, I'm going to get secant times secant. That's going to give me secant squared theta. The next thing I'm going to get is secant times positive 1, which is positive secant theta. I continue, and now I'm going to get a negative secant theta, which is nice because those last two terms are going to cancel out. And I'm going to get minus 1. So now all of a sudden I've got secant squared theta minus 1. And I want this to be equal to tangent squared. So now how do I get this side to be tangent squared? Well, now's where those squareds come in, okay? We want to remember that we have something called the Pythagorean identities. So those Pythagorean identities are listed right here. And the one that I want to make use of is the one for tangent. Okay, tangent squared plus 1 equals secant squared. That means anywhere I see a secant squared, I can replace it with tangent squared plus 1. So I'm going to take this tangent squared plus 1, and I'm going to move it right where I used to have that secant. I'm going to change that angle. We're dealing with theta in this case, not x. But what I've done is I've made use of the identity, because where I saw secant squared theta, I've rewritten it as tangent squared theta plus 1, the Pythagorean identity. Those are exactly the same. When I do that, some wonderful things happen. The 1 and the negative 1 cancel. So I am left with tangent squared theta. And that means we have shown that the left side, tangent squared theta, and the right side have the exact same value. So the idea here is using factoring and foiling in some of the examples we're going to be looking at. So here's the first one. Let's look at this next one. Again, we want to establish this identity. We want to prove it's true. Now, this looks a lot like the other one. We could just start off foiling it all out. But this time what I notice is I've got the squared right away. I've got that Pythagorean kind of identity going on. So if I bring those back and I look at those Pythagorean identities, what I know is I've got sine squared plus cosine squared equals 1. There's my cosine squared. There's a 1. What I want to try to do is I want to try to manipulate this identity. So I'm just going to bring this down here for a second, and I'm going to say this. What would happen if we subtracted cosine squared x from both sides? Well, something wonderful would happen, because what we would see is sine squared x, and these would cancel out, and that would be equal to 1 minus cosine squared x. So what we can say now is that everywhere we see 1 minus cosine squared, we can replace it with sine squared. So in this example, I hope it was clear that we're locking down the 1. I'm not touching that 1 for the life of me. But now what I'm going to do is I'm going to take the other side, and where I had 1 minus cosine squared, I'm running sine squared instead. So that is going to be sine squared. I am going to keep that 1 plus cotangent squared. I'm not touching that guy yet. That might have an identity I can use, but I am going to leave it exactly the way it is. I also am going to notice that I should have had an x there, not a theta. We got to be consistent. So that should have been an x, okay? So now what I've done is I've replaced the 1 plus cosine squared with sine squared based on the Pythagorean identity. Perfectly legal. We're ready to roll. We're keeping this one the same. And now comes the factoring and the foiling. We're multiplying this out. We're distributing. So we're going to get sine squared x plus, and now we're going to have sine squared x times cotangent squared x. Well, somehow this side has to be equal to 1. We got to keep working with this until we can get this equal to 1. So now what I want to do is I'm going to leave the 1 on that side. I'm going to leave that sine squared exactly where it is. And now I'm going to start playing with this sine squared cotangent squared. One of my favorite things to do is to write everything in terms of sine and cosine. See how everything relates. Cotangent, you may remember, is cosine over sine. But if I'm squaring it, that means I'm going to get cosine squared over sine squared. Okay, so what I've done here is I've replaced this cotangent squared with its equivalent in terms of sines and cosines. Now by doing that, something great's going to happen. I've got a sine squared on the top and a sine squared on the bottom. Those are going to cancel. I've still got that one I've been dragging along, but now I've got sine squared x plus, and what survives? Cosine squared x. Well, that is the Pythagorean identity I want. You may remember it. I had it before. I'm going to have it again. Let's bring it back real quick. There it is. It's this top one. Wherever I see sine squared plus cosine squared, I can replace it with 1. I'm definitely seeing sine squared plus cosine squared here. I am replacing that with 1. So we have shown how to manipulate this to make both sides 1. We have verified this identity.